recent study out of MIT examined 300 real-world enterprise AI projects to see exactly how they performed in production environments. This visualization charts those 300 projects. As you see, 95% rapidly go offline, producing zero measurable business impact. The remaining 5% of active nodes show the underlying models perform as intended. The failure isn't the AI itself. The friction happens during integration. Sleek, modern AI models grind to an absolute halt when forced to interface with heavily rusted, mismatched legacy enterprise pipelines. Success in the AI era relies entirely on bridging the brutal gap between state-of-the-art AI and messy real-world infrastructure. Traditional software engineering operates within a highly structured, predictable environment. Enterprise AI integration, however, is chaotic and highly restrictive. Many junior developers fall for the API illusion. They assume implementing AI means sending a prompt to an API and parsing a JSON response. To force integrations to work, elite AI labs have heavily adopted a methodology known as forward-deployed engineering. True production deployment requires engineers to embed on-site and wire LLM logic directly into a company's idiosyncratic, half-finished internal systems. To survive as an AI builder, engineers must move past toy chatbots to architecting production-grade agentic workflows. To understand exactly how this transition works, we will construct a production-ready enterprise AI agent entirely from first principles. This schematic shows the baseline architecture of a standard naive AI chatbot, where a single LLM handles a simple request directly from the user. When we introduce this fragile, monolithic architecture to the reality of a corporate backend, it immediately hits a tangled web of legacy databases and strict regulatory constraints. The system hits immediate technical walls. The context window overloads, and rigid authentication blocks snap the connection to the legacy database entirely. The business consequence is severe. The system crashes, stakeholders lose trust, and the AI project yields zero return on investment. A single prompt architecture physically cannot handle the ambiguity and security demands of legacy enterprise systems. The solution to complex enterprise workflows requires a complete architectural pivot towards extreme problem decomposition. This updated diagram introduces a router node. It intercepts ambiguous user requests and translates them into actionable technical plans. Under the router's command are subagents, highly specialized, narrow-focus models operating hierarchically. Giving each subagent a strict single-task mandate drastically reduces hallucinations and context bloat. In a concrete workflow, subagent A is strictly isolated to query a Postgres database, while subagent B handles the handshake for external API authentication. Robust enterprise AI engineering relies entirely on orchestrating a precise network of highly specialized subagents. This architecture creates a massive friction point. Hand-wiring the custom connections between all these subagents and varying legacy tools is excruciatingly tedious. This diagram now highlights the Model Context Protocol, or MCP, which acts as a standardized communication layer for AI models. MCPs allow subagents to uniformly read and write data without the engineer needing to build custom wrappers for every single proprietary tool. To manage this infrastructural plumbing, agentic coding tools like Claude Code or Codex serve as mandatory force multipliers. These AI tools are deployed to write the boilerplate integration logic directly on the customer systems, drastically accelerating the build phase. In modern production environments, the human acts as the system architect, resolving ambiguity, while the AI tools handle the manual plumbing. The final, most critical hurdle of AI deployment is guaranteeing deterministic, safe behavior inside a probabilistic system. This diagram illustrates an eval harness, a rigorous system of automated quality checks and constraints surrounding the subagent cluster. The eval harness statistically proves to stakeholders that the agent can catch and filter out bad outputs, resolving edge cases without hallucinating damaging information. Physical deployment then moves from local development to pushing the final system onto live infrastructure, like GCP or AWS. Engineers often face extreme constraints during this phase, such as operating within highly secure, air-gapped networks with zero internet access. The final step of the pipeline encapsulates the entire agentic architecture inside a Docker container for isolated, reliable execution. Verifiable reliability and secure, containerized deployment are the exact metrics that separate a toy project from a production asset. we have traced the complete evolution of the architecture, moving from a single, fragile API call to a fully containerized, rigorously evaluated agent workflow. Delivering this complete, final architecture into a live production environment demands a massive scope of work and complexity from a single engineer. The daily reality of this integration work involves heavy plumbing, system design, and customer handholding. It is a stark contrast to the traditional view of pure, isolated software engineering. An engineer must also possess radical ownership, staying with the messy deployment until a measurable business outcome is achieved. The real skill gap in AI is elite system design and the resilience to tame environmental ambiguity. Direct, urgent tone. Continuing to build isolated chatbots in Jupyter notebooks will actively stunt a software engineer's career in the current market. Instead, find a genuinely messy, unstructured public dataset and identify one real-world bottleneck. Build one complete end-to-end agentic workflow to solve that specific narrow bottleneck. Wire it to real infrastructure, wrap it in a strict evaluation harness, and deploy it in a Docker container. Mastering the agonizing last mile of integration is the only way to bridge the 95% failure gap and establish yourself as an elite AI builder.